Hi children, in aim number 4 we have learned laws of the logarithms and logarithmic equalities and logarithmic inequalities. Now in this aim number 5 we are going to learn applications of the logarithms and also types of the logarithms according to the base and the terms related to the logarithms. Now first we are going to see types of logarithms. Types of logarithms. If the logarithms are calculating to the base e are called, that means log a to the base e are called, here base is e, natural logarithms. Natural logarithms are Napier logarithms. Natural logarithms or Napier logarithms. Usually it is denoted as ln a. ln is nothing but logarithms with the base a, base e. Now come to the second type, log a to the base 10, and what do you observe here? Base is 10. If the logarithms are calculated with the base 10, those logarithms are called common logarithms. Common logarithms. Otherwise, Briggs logarithms. Common logarithms or Briggs logarithms. Here, logarithms according to the bases, there are two types. Logarithm with the base e, logarithmic number with the base 10. Often we are using these common logarithms only for application purpose. Now terms related to the logarithms. First one is characteristic. Characteristic of a logarithm. The integral part of the logarithm is called characteristic of the logarithm. Integral part. Suppose log n to the base a is equal to 3.4697. What is its integral part? 3. This 3 is called characteristic. It can be denoted using greatest integer function. Log n to the base a step function is equal to 3. Its integral part. That integral part is known as the characteristic of the logarithm. See some examples. Log 8 to the base 3. What is its characteristic? To get the characteristic of any number, and where is that logarithmic number, where it is, and we are going to write that number in between powers of the consecutive powers of the 3. That is, 8 lies between, 8 is 3 power 0 is there, 3 power 0 is 1, 1 is less than 8, 3 power 1 is also less than 8, 3 square is greater than 8, so that it lies between the two consecutive powers 3 power 1 and 3 square. Therefore, apply the logarithm with base 3. Then log 3 to the base 3 is less than log 8 to the base 3 is less than 2 log 3 to the base 3, which is equal to 1 less than log 8 to the base 3 less than 2. What is its integral part then? Its integral part is equal to 1. Therefore, characteristic of log 8 to the base 3 is equal to 1. In a similar way, we can write log 0.5 to the base 2. 0.5 is nothing but 1 by 2. 1 by 2. What is its value? 1 by 2 less than or equal to 2 power minus 1. 2 power minus 2 less than 1 by 2 less than or equals to 2 power minus 1. Two consecutive integers, minus 2 and minus 1. Otherwise, 1 by 4 is less than 1 by 4 is less than 1 by 2 is less than or equals to 1 by 2. Therefore, 2 power minus 2 is less than 2 power minus 1 is less than or equals to 2 power minus 1. Therefore, what is its characteristic? Minus 1. Because of apply the logarithms on both sides, then 1 by 2 lies between minus 1 and minus 2. Minus 2 and minus 1. Its characteristic is minus 1. Point something is there, that is it correct or not? Once check it. Minus 2 less than 2 power minus 1, its value is equal to minus 1. Decimal point part is 0, decimal part is not there. Minus 2, apply the logarithms. Minus 2 less than log 1 by 2 to the base 2 less than or equals to minus 1. Therefore, directly it is equal to minus 1. Therefore, its characteristic is equal to minus 1. One more example. Take one more example. Log 5 0.1. Log 5 0.1, what is its characteristic? First of all, question yourself, where is 5? In between the powers of the 0.1. In between two consecutive powers of the 0.1, we have to find that 5 value. 5 lies between 0.1 whole power 0 and 0.1 whole power minus 1. 0.1 whole power minus 1 is nothing but its value is 10. 0.1 whole power 0 is nothing but its value is 1. In between 1 and 10, 5 is there. Therefore, these two are consecutive integers also. Apply the logarithm with the base 0.1. Then what do you get there? It becomes log 0.1 whole power 0 to the base 0.1. Here I am applying the logarithms with the base 0.1, which lies between 0 and 1, so that inequality will be changed. Greater than log 5 to the base 0.1 is greater than log 0.1 whole power minus 1 0.1. Finally, what do you get there? 0 is greater than log 5 to the base 0.1 is greater than minus 1 is greater than. Therefore, what is its integral part then? Minus 1. Minus 1 is its integral part. And log 1 characteristic is equal to log 1 characteristic is equal to log 1 is equal to 0. Therefore, its characteristic is 0. From these examples, we will get one conclusion. Characteristic is in either negative integer or positive integer or 0 also. Now, come to the Another term related to the logarithms is Mantissa. What is meant by Mantissa? The decimal part of the logarithm is called Mantissa. Suppose, for example, log 50 to the base 10 is there, its value is 1.6990. What is its decimal part? 6990, 0 point. Therefore, its Mantissa is equal to 0.6990. Decimal part only we have to consider. Mantissa is always positive, and it takes 0 and greater than 0 values, and but less than 1. Because as it is the decimal part lies between 0 and 1, it takes 0 also, but it doesn't take 1. Therefore, if Mantissa is equal to some a, we can write the range of the Mantissa as 0 less than or equals to a less than 1. Mantissa is always positive, whereas the characteristic is any integer. Now, after learning these two, now we are going to see what are the uses of these characteristic and Mantissa. Mainly we are going to use this characteristic and Mantissa for finding the number of digits in the given number. Otherwise, the number of zeros in between decimal point and the first significant number. These are main applications of the characteristic. To find the Mantissa of the logarithm, we have to depend upon the logarithmic tables. In next time we are going to learn how to see the logarithmic tables. Now in the same, the important applications of the logarithms using this characteristic. Now see, log n to the base 10 is there. How to find the characteristic of the logarithms which are calculating to the base 10? No need to find the characteristic of the logarithms with the base 10 in above said process. There is a particular rules for that. In that, first rule is working rules. These are called working rules for the base 10 only. Children, very clearly you have to observe, characteristic is defined for any logarithms with any base. But with base 10, there are two working rules. Using of those working rules, we can find the characteristic of the logarithms with base 10 very easy. Therefore, first working rule, what we have to observe? Actually, these working rules can be obtained from the process of the finding of the characteristic only. But these are the generalization forms. To say the characteristic very easily, we have to use these working rules directly for solving the problems. Now, if n is greater than 1, n has k digits in it, n has k digits, then characteristic of log n to the base 10 is equal to k minus 1. Number of digits minus 1. For example, log 569 to the base 10. What is its characteristic? 569 is the greater than 1. We have to check it whether it comes under this working rule or not. 569 has 3 digits. Now, what is its characteristic? Its characteristic is nothing but 3 minus 1, which is equal to 2. Now come to the next rule. If 0 less than n less than 1, this is the second rule. If 0 less than n less than 1 and n has k zeros in between decimal point and first significant number. In the second case, if 0 less than n less than 1 and n has k zeros in between decimal point and first significant number, then characteristic is equal to minus of k plus 1. It is denoted as k plus 1 bar. What is the need to keep that minus as the bar of that number? Later we will get the clarity. Let us see once these two rules once remember. If n is greater than 1 and n has k digits in it, then the characteristic of that log n to the base 10 is equal to k minus 1. If n lies between 0 and 1 and n has k zeros in between decimal point and the first significant number, then the characteristic is equal to k plus 1 bar. For example, log 0.00078 to the base 10. What is its characteristic? What is its characteristic? Because of base 10 is there and this number lies between 0 and 1, and how many zeros it has in between the decimal point and the first significant number. First significant number means non-zero digit. Non-digit to zero digit is 7. Therefore 3 zeros it has. Therefore characteristic is equal to minus 3 plus 1, which can be written as 4 bar. Therefore its characteristic is equal to 4 bar. These two are the very important working rules for finding the characteristics with base 10. Log n to the base 10 is equal to minus 3.4664. What is its characteristic and what is its Mantissa? First of all, what do you understand by seeing this minus 3.4664? Here, what is the meaning of minus 3.4664? Minus 3 plus minus 0.4664. To say this minus 3 as the characteristic and minus 0.4664 as the Mantissa, it is not the decimal point. It is not the decimal part. Minus 3 is the integer, okay, but it is not the decimal part. Decimal part is always positive, lies between 0 and 1 only. Therefore, need to do something here, that is, we have to make this as positive without changing this value. That is, add plus 1 and subtract 1. Then what do you get there? Minus 3 minus 1 minus 4 plus 1 minus 0.4664, which is equal to, it can be written as 4 bar point 6 3 3 and again 5 3 3 6. 4 bar point 5 3 3 6. Children, did you understand why we are keeping this bar for the characteristic only? Why don't we keep this minus before this number? If you keep if you keep this minus before this number, then this minus belonging to the decimal part also. But this bar shows this minus belongs only for the integral part. So that this minus 3.4664 is equal to 4 bar 0.5336. Both are equal, both values are equal. But here in this decimal part is also negative. Here it is decimal part is positive and this is negative. Now characteristic of this logarithmic number is log n to the base 10 is equal to 4 bar. Mantissa is equal to 0.5336. Is it clear, children? This is very important point to learn. Once again, log n to the base 10 is equal to minus 3 point something is there. To decide which is characteristic and Mantissa, we need to do something. Before minus, if you keep automatically that minus belonging to the decimal point, decimal part also. So that in this decimal part, to say Mantissa, decimal part should be positive. Therefore, we need to do some process here. Then it becomes as 4 bar 0.5336. In this 0.5336 is positive value, so that we can say this is as the Mantissa. 4 bar is the characteristic. Now, using this characteristic and Mantissa, how can we find number of the digits in the given number and the number of zeros in between first significant number and the decimal point? If the log n characteristic is equal to k, if log n characteristic is equal to k, first observation, if k is positive, characteristic is positive integer or negative integer is equal to 0 also, characteristic. If k is greater than 0, then n is greater than 1 and n has how many digits? K plus 1 digits. N has k plus 1 digits. That is the reason if n has k plus 1 digits, by the working rule of the finding of the characteristic we have, if the n has k digits, then its characteristic is equal to k minus 1. If its characteristic is equal to k, then n has k plus 1 digits. That is the first point. Second point, if k is equal to 0, if k is equal to 0, n is equal to 1. N is equal to 1, that number is equal to 1. Third case, if k less than 0, if k is less than 0, what do you say? N has how many zeros are there? N is less than 0 and less than 1 and greater than or equal to 0. Since strictly k less than 0, k is a negative integer, n lies between 0 and 1 only. Now, my question is, how many zeros it has in between the decimal point and the first significant number? Again, once observe the example. Log 0.01 to the base 10 is there, otherwise log 0.02 to the base 10. What is its characteristic? 1 0 is there, therefore characteristic is equal to 2 bar. Therefore k less than 0, therefore characteristic is given as 2 bar. And how many zeros it has means? Minus of, it has, this is k less than 0, minus k, minus 2 is there, minus k plus 1, which is equal to minus of, we have to k. Because of minus k plus 1 is the negative. To make that is as positive, minus of minus k plus 1. Zeros it has. zeros are there. N has minus of minus k plus 1 zeros in between the decimal point and the first significant number. Children, once again remember, if k greater than 0, n has k plus 1 digits. If k equal to 0, n is fixed as 1. If k less than 0, n has minus of minus k plus 1 zeros. Observe this example. Because of if it has 1 0, then 1 plus 1, its characteristic is equal to minus 2. If it has a characteristic is equal to k, that is equal to k is there as here k is equal to minus 2. Minus 2 plus 1, which is equal to minus 1. Minus of minus 1, 1. Therefore 1 0 it has. Therefore we can able to find the number of digits in the given number if it is greater than 1. Otherwise the number of zeros in between the decimal point and the first significant number if you know the characteristic, either it is positive or negative according to it. Now come to observe some examples. Log 0.2. What is its characteristic? Its characteristic is equal to 1 bar. Log 2. What is its characteristic? 1 bar point. Its value is equal to, characteristic is 1 bar and its value is equal to 3010. Mantissa 1 bar point 3010. Log 2 is equal to 0.3010 and log 20 is equal to 1.3010. And what do you observe, children? Mantissa doesn't change, only the characteristic changed here. Mantissa, when do we get the same Mantissa? If these logarithmic numbers are multiplied with 10 power k times. That is, m is equal to n into 10 power k. We have one point, that is log m comma log n are having same Mantissa, but they may differ in their characteristics. This is very important point and need to remember also. Sometimes we have to use this application. Log m, once again, if m is equal to n into 10 power k, then log m and log n are having the same Mantissa but different characteristics. Now come to the examples. Find the Mantissa of log 1 by 16 to the base 10 is equal to minus 1.2040. This is given there. Now I have to find the Mantissa and characteristic also. Already we have known the process. Here minus 1 belonging to 1 and 0.2040 also. Therefore we can't say 0.2040 as the Mantissa. Therefore it can be written as minus 1 plus minus 0.2040 and add 1, subtract 1. Then minus 1, it can be written as 2 bar plus 1 minus 0.2040, which is equal to 2 bar 0.6, 9 minus 4, 5, 9 is there, and after that 9 minus 2, 7. No. Let's observe. Subtract 0 and after that 6 is there and after that 9 is there and after that 7 is there. Therefore 2 bar 0.7960. Therefore children, what is its characteristic? 79.2 bar is the characteristic, 0.7960 is the mantissa of this log 1 by 16 to the base 10. Now come to the another problem. Number of digits. Log 2 to the base 10 is equal to 0.3010. Find the number of digits in 8 power 25. 8 power 25, number of digits. It is very difficult to compute the value of the 8 power 25. If you apply the logarithms, it is very easy to compute it, find it, number of the digits in this 8 power 25. Let it be some x. Apply the logarithm on both sides with the base 10, then it becomes as log 25 log 8. Again log x is equal to 25, 2 cube, it can be written as 2 cube, 2 cube into 25, 75 log 2. Log 2 value is given as 75 into 0.3010 and multiply 0.301 into 75, 5, 0, 15, 7, 0, 21, 5, 7, 5, 2, 2, and after 3 zeros you have to keep. Now its value is 22.575. Therefore this log x value is 22.575. Its characteristic is equal to 22. Therefore number of digits in x is equal to number of digits in x is equal to 23 by known point. Children, in aim number 5 we have learnt types of the logarithms according to the base, and the terms related to the logarithms, those are characteristic and mantissa of the logarithm. Characteristic may be a positive integer, negative integer, or 0 also, but mantissa always positive number and it lies between 0 and 1. And applications of the logarithms, the most important applications of the logarithms is finding of the number of the digits using the characteristic. And how to find the characteristic for the different cases also we have learnt in aim number 5. And to find the mantissa we have to depend upon the logarithmic tables. How to see logarithmic tables we are going to learn in next aim.